Hi friends, welcome to this video. Hope you have gone through the previous videos in machine learning uploaded by me. So if not, you can go through the playlist of machine learning. So in this video, I am going to explain about ensemble learning. So it is coming under this third unit of classification and temporal models. So in this third unit, we have already seen artificial neural networks, and now we are going for ensemble learning. So first of all, we want to know what is this ensemble learning. So ensemble learning technique, it is the combination of various models together to improve the performance of the model. So as we know, each model will be having some kind of positiveness and some kind of negativeness, advantages and disadvantages. So we are going to combine different models together to improve the performance. So that is what here it is, combine individual modules together to improve the stability and predictive power of the model. So what is this ensemble learning going to provide for the user is high predictive performance. So the user, the predicted data that the user is going to obtain from the model is high predictive performance. So it actually combines multiple machine learning models. That is what mentioned in the first point. So it combines multiple machine learning models into one predictive model. So what happens is the advantages of these different machine learning models can be obtained in a single model. So as I said, certain models do well in some modeling aspect, but when coming to another aspect that may fail. So in such a situation, you are going to use the positive side of those methods. So instead of learning a complex model, what you are going to do is learn the simple models that are available or that can be used for the particular problem, then combine their output and come to the final decision. So this is what this ensemble learning is. So as we are going to combine these models together, so the combined strength of the models affect individual variance and the biases. So this provides a composite prediction where the final accuracy of the output, the final prediction or the final output is better than the accuracy of all those individual models. So this is the major advantage of this ensemble learning. So let us look into the work. The ensemble learning, how it works, that we are going to see now. So this ensemble methods, there are two different methods that we can see one by one. The first method is the sequential ensemble method. This sequential ensemble method, what it does is the base learners are generated consecutively in this sequential ensemble method, and the basic motivation is the dependence of the dependent between the learners, and the overall performance of the model can be boosted. So these are some of the things related to this sequential ensemble method. Then coming to the next type, that is the parallel ensemble method. Here it is this parallel ensemble method can be obtained or applied whenever the base learners are generated in parallel. The best example for this parallel ensemble method is the random forest. So in random forest there will be number of decision trees which will be performing its operation in a parallel way, and it will be generating the learning outcome in a parallel way. So that is the best example for this parallel ensemble methods. The basic motivation behind using this parallel ensemble method is the independence between the base learners. So in sequential ensemble method, we are going towards the dependence of the base learner, and in case of parallel ensemble method, we are going with the independence between the base learners. Next is how this is working. So here you could see there are three models of machine learning. I am going to have it in my example. So the model 1, model 2 and model 3. So three machine learning models, and the outcome from these three machine learning models can be together forms the ensemble model. So the ensemble model is the combination of these three different machine learning models, that is model 1, model 2 and model 3. Now we are getting the input for this ensemble model. So this will perform the learning operation, and it is going to predict the output prediction. So this is how exactly this ensemble learning is going to work. So the ensemble model is the combination or collection of various models of the machine learning models, and it will be getting the input, processing it through these different models, and combining all the predictions from these different models, it gives the final prediction. Next is ensemble learning significance. What is the significance of using this ensemble learning? So it is an application of multiple models to obtain better performance than the single model. So here we are going to obtain a better performance from using a single model to a combination of multiple models. So when coming to the performance depends on two major factors. The first one is the robustness. It incorporates the predictions from all the base learners. And the second one is the accuracy, which deliver the accurate predictions and have improved performance. So these are the two major factors based on which the performance of the ensemble learning is being measured. Next we could see the methods by which this ensemble learning can be performed. So the first one is for this ensemble learning, the first thing we are going to do is combine all the weak learners to form an ensemble. Here what is the term weak learners I am mentioning here is, it is just the various machine learning models that we are going to combine. So those machine learning models will be providing the predictions which are not so accurate. So we call them as a weak learner. So these output or the predictions obtained from the machine learning models will be combined together, or the output from these weak learners are combined together to form a better output. So here first what you are going to do is combine all weak learners to form an ensemble, or you can create an ensemble of well-known, strong and diverse models. So if you are in need of getting a strong method by combining any of the two models, you can do that also. This ensemble model, it gain more accuracy and robustness by combining the data from numerous modeling approaches. So this is the best thing that why we are going for this ensemble learning. So the first method we are going to look in this ensemble learning is averaging. So let us see how this works. This ensemble learning averaging concept, it works by getting the amount of predictions from various models and taking the average of it. So each ensemble models contribute the equal amount for obtaining the prediction. So let us look into an example here. Here I am using three different machine learning models: decision tree, logistic regression, and super vector machines. So these three are different machine learning models, and it will be giving its own predictions, and we are going to get an ensemble prediction by making the average of these three. So P1 will be the prediction from decision tree, P2 will be the prediction from logistic regression, and P3 will be the prediction from the support vector machines. We are going to get the average of these three machine learning models to get the ensemble prediction. So a class label is predicted using the mode of member predictions, and also the class probability is calculated as the argument that gives the maximum value of the summed probabilities for each class label. We normally say using a term called argmax. So that this argmax is the argument that gives the maximum value of the summed properties. So argmax is the argument which gives the maximum value. And here in this average, you are assigning equal weights for all the methods or the models which are being used. And we can move to the next method, that is weighted averaging. So here you are going to put some weight over the each model. So in this example you could see the same three different machine learning models I have used here: the decision tree, the logistic regression, and the super vector machine, and I am giving the weightage to each of the modules. The decision tree a 50% weightage, for logistic regression it is 35%, and for super vector machine I have given 15% of weightage. So likewise, giving weightage to the model and getting the exact prediction is called as weighted averaging. So what are the things you need to consider is model weights are the small positive values, and the important norms or the rule that you need to follow is the computation or the sum of all those models weight is equal to 1. So as we have seen in the previous model, the 50%, that is 0.5, then the 0.35, and then 0.15. The sum of all these three will be giving the value 1. So this is a condition you need to follow for putting the weights. And the percentage of trust over this expected performance will be calculated using the performance index, that is P is equal to, that is the expected performance, and which is equal to W1, that is the weight 1, into the P1 plus that is related to the first model, and W2 P2, that is the second model, and W3 P3, the third model. The contributions of each member or each model that comes under this ensemble learning will be decided by the weightage of the model. So whatever weightage you are going to put over those particular model, that will be the contribution of the each. And the next method in ensemble learning is bagging. So it is combining the results of the model together to get generalized results. So here in bagging or bootstrap aggregation, it reduces variances of an estimate by taking the mean of multiple estimates. So what may be the formula for that is f of x is equal to 1 divided by m into the sum of all those fm of x. So this will give the exact mean of the multiple estimates. So let us look into an example through which you can see the different steps by which the bagging is performed. So this is an example. So here first you are going to have the original data set, then you are going to make the sample, then you will be getting some model, and from that you can get the exact output. So these are the different methods that are being carried out for completing this bagging process. So let's see one by one. The step 1, it create randomly sampled database or data set of the original training data. This step is called the bootstrapping step. And in the step 2, you are going to build and fit several classifiers to each of these copies. So you have made the sample and now you are going to put the classifiers. And in the third step, you are going to take the average of all the predictions to get the final overall prediction. So these are the 3 steps through which this bagging or bootstrapping is going to work. And the next concept or the method in ensemble learning is boosting. It reduces bias by training weak learners sequentially, each trying to correct its predecessor. So it is going to boost the output. So it reduces the bias by training the weak learners. So you are going to train the weak learners again, and you are going to correct the error which was made in the previous iteration. This is what you are going to do in this boosting session. So for example, let us consider a particular person who is having a headache, stomach pain and leg pain. So he need to go to a doctor, and there the doctor will be analyzing the reason for these headache, stomach pain and leg pain. And the reason can be the X, it causes the headache but not the leg pain. Who is causing the leg pain is Y. And the stomach pain, it is not caused by either X or Y, but the stomach pain is caused by Z. So these are the conditions we are having. So now the person is going to Doctor 1. So Doctor 1, what he identifies is headache is surely caused by X, but he is not able to explain the other reason for other problems. And he goes to the next doctor for an opinion, who agree that X is causing the headache. Also he find that Y is causing the leg pain, but he is not sure about the stomach pain. So what he did is, he is going to the next doctor's opinion. He agrees X and Y for a sort, and he identified that Z is the reason for the stomach pain. So the final diagnosis is based on the result of the weighted opinion. That is, the person is now here, he need to identify which doctor's prediction is he is going to obtain. So that is based on the weight. So if he is putting the entire belief over Doctor 3, so he is going to get that Z will be causing the stomach pain. This is an example by how this boosting is going to occur. So the same problem, we are going to get another and another and another opinion, so that you will be getting an exact output. So the step 1 in this boosting is you train a classifier that best classifies the data with respect to accuracy. So first step, you are going to train it. Then identify the regions where H1 produces errors. So you are going to identify the errors. Then you are going to put some weight to them, and now you are producing the H2 classifier. And in the third step, you are going to aggregate those samples for which H1 gives a different result from H2 and produces the H3 classifier. And if there is any new classifier coming, you need to repeat this step 2 again. So this is how this boosting algorithm is working. And the next method of ensemble learning which we are going to learn is Adaboost. So this is a boosting technique of changing weak learners into a strong learner. So each new tree is a fit on a modified version of the original data set. So what this is going to do is it first boosts the algorithm and then it solves the problem. So what is the advantage of using this Adaboost is it helps in mixing multiple weak classifiers into one strong classifier. How this Adaboost works? So first it assigns equal weight to each data point and apply a decision sum to classify as plus and minus. So here we are going to get a decision tree. So based on a color, if it is yellow it goes to lemon, and if it is green it goes to lime. And for this, the most appropriate algorithm in Adaboost is the decision tree algorithm. For different attributes, the tree consists only of the single interior node, and then in this example, this is the first iteration we are having. So here 2 plus simples is been identified or grouped correctly, even though the 3 were kept out. So now apply higher weights to incorrectly predicted these 3 plus and add another decision stump. So in the next decision stump, what you are going to do is the size of the 3 incorrectly predicted plus is made bigger than the rest of the data point. So you are adding these 3 pluses there, and now these minus were taken. Here also again comes the problem, that is there are 3 more minus left. So the second decision stump will try to predict them correctly, but what happens, it misclassified the plus. So there are misclassification error to the 3 minus signs. So we are going for the next step where you are going to add higher weights to the 3 minus. And in this iteration you could see we have horizontally splitted those positive plus and minus. So a horizontal line is generated to classify the plus and minus based on higher weight of misclassified observation. So we are making the final classifier, which almost given the right thing as the 2 plus simples. So where the D1, D2, D3 are combined, which gives the strong prediction and a more complex rule than the weak learners. So this is how this Adaboost is going to work. So here the step 1, it selects a training subset randomly, then it iteratively trains the machine learning model, then it assigns a higher weight to wrongly classified observations, and it assigns weight to the trained classifier in each iteration based on the accuracy of the classifier. And the last step is this iterates until the complete training data file without any error. So these are the steps by which this Adaboost is working. Hope now this ensemble learning is clear to you. So to make this ensemble learning, there are lots of things behind it. So this video become little a lengthier video. Thank you for watching.